Greetings to you, my learners. I welcome you to this wonderful class, the class of additional mathematics. With me here is the question on the chalkboard, which is going to be our today's lesson. Find the equation of the norm to the curve y is equals to 5 over x plus 1 at a point where x is equals to -2, 6 marks. Okay. So what is it that we are supposed to do for us to find the equation? So when finding the equation, there are two important things that you must actually put into place. And these are gradient coordinates. So let's get back to the question and see if at all we have those things that I've mentioned in the what? In the statement that we have. We don't have a gradient there. We only have x coordinate. Okay, so let us first find the gradient of this same curve that we are given, and thereafter that's when we are going to find the equation of the norm. Remember, the equation of the norm is a straight line. Okay, we have a tangent line which is actually attached, okay, to the curve. Then out of that same line, there is another line which is now perpendicular to the tangent line, and it's the one which is called what? The equation, the norm line. So it's the one that we are going to find. Okay? Yes. So now let us come to the equation. The gradient of this same curve. How are we going to find the gradient of this curve? Very interesting. Okay. So what we are going to do for us to find the gradient of this curve is actually by doing what? Differentiating. Remember, differentiate is the alternative word of the gradient. When we are dealing with the equations, the curved ones, the equations which are curved, like this one, we use dy dx. Now, when we are dealing with the straight line equation, that is where now we say gradient, but it is just one and the same. So this is what we are going to do. So how are we going to find this, the gradient of this one? Let us look at the curve that we have. Actually, this one is a radical what? Function. So when it is radical function, there are certain rules that we can apply for us to find the gradient. Okay. So for this one radical, we use what is known as the quotient rule. Okay, quotient what? Rule. So if you get back, if I take you back to the previous lesson that we had, we actually looked at this exact, the quotient what? Rule. So the quotient rule is only applied on radical what? Functions. So let us go, let us actually proceed and see how we are going to find the gradient of this same one. Okay, so g of x, f of x prime minus f of x, g of x prime over g of x squared. Okay, now from there we can substitute. Let us substitute now. Okay, bearing in mind that g of x is the denominator, f of x is the numerator. Okay, so now g of x, since g of x is the denominator, so where there is g of x, we are going to put x plus 1. Okay, times, we just open the bracket there. Then f of x prime, so whenever you see this simply means differentiate. Okay, prime is same as what? Differentiate. So we need to differentiate the f of x, which is the numerator. What is the differential of the constant number? A constant number, when we differentiate it, we are going to have a 0. So here we put a 0. Okay, then f of x we know is what? 5. So we are going to write 5. Okay, we open the bracket. G of x prime, we need to differentiate this time around. We need to differentiate this one. So when we differentiate x plus 1, remember, x, you are going to have 1. When you differentiate the variable, the answer is 1. Then plus, the constant is 0. So 1 plus 0 is 1. So we are going to write 1 here. Okay, so we are done with the numerator. Then we come down here. G of x, we just get this, then we square. Okay, so x plus 1, we are going to square that one. Then from there now we can simplify this. X plus 1 times 0, the answer is 0, automatically 0. Then negative 5 times 1 is negative 5. Okay, over the denominator, we just drop it down like the way it is. And just bring it down there. Square. Okay, then from there, we can tell that this is now 0 minus 5 is negative 5 over x plus 1 squared. Okay, so this is the differential of this scale. Okay, now when we get back to the information that we have, they are saying where x is equals to negative 1. So it means once you reach on this stage, you are now going to substitute where there is x, put negative what? Negative 1. Okay, this is what we are going to do. So where there is x, so we have negative 5 over, we have where there is x, we have to put negative what? Negative 2. This is what they are telling us. Plus 1. Okay, the negative 5 over, this one we are going to have negative 1. Okay, then the square root of negative 1, that one is negative 5 over the square root of negative 1. What is the answer? The answer is 1. So 1 into negative 5, the answer is negative 5. So our gradient to this curve is in negative what? Negative 5. Okay, that is our gradient to this curve. Now that you have known the gradient, I think this time around, actually the gradient that you have found is just for the curve and the what? The tangent line. Now let us talk of the perpendicular line, which is the what? The curve, the norm. So then the perpendicular line of that tangent, how we are going to find it, and that is the gradient that we are going to use even when finding the equation of that same norm. So let us do it. So what normally happens here, we have negative 5. Okay, so what we do there, the simplest way of finding the gradient of the norm is just to reciprocate, okay, and negate. So what do I mean when I say that? We have here, for example, we have 5, that is the one we have. Remember, this is over 1. You must know that, okay? Every whole number is over what? 1. So now, reciprocate, it means that the denominator will become the numerator, and the numerator has to be the denominator. This is what it means to reciprocate. So now, this one is going to be 1 over what? 5. Okay? And it should be positive. If it is negative, when it is reciprocating, it changes its sign to what? Positive. Then if it is positive, when it reciprocates, it is going to change its sign to what? To negative. That's what happens. So this is the gradient of the norm line, the one that we are looking for. Now that we have known the gradient here now, we have known the gradient, okay? So the gradient is 1 over 5. 1 over 5. We can go on now, finding the what? The coordinate, the equation. Now before that again, we should also look for coordinates. Remember, I did mention that you should have 2 things in place, gradient and coordinates. So coordinates we don't have. So let us find. How are we going to find the coordinates? We are given the what? The x there. So we are just going to substitute. Where there is the, we get y. Okay, we get y is equals to 5 over, here we just put 2 plus 1. Okay, so 5 over, when we do this, this one is going to be negative 1. So our y is negative 5. Okay, so when x is equals to negative 2, y is negative 5. So this would be our coordinates. So negative 2, negative 5. Okay, so these are the ones that we are going to use when finding the what? the equation of the norm. So now let us apply now the formula, the gradient point form for the what? For the straight line equation. That is the one we are going to apply here, because the norm which they are asking us to find here is a straight line. So we are going to say y minus y1 equals m, open bracket, x, okay, plus, x minus x1 cross. So this is what we are going to do. Then from there, we substitute, okay? We substitute accordingly. So y1 minus, y minus y1. So our y1 is what? Our y1 is negative what? Negative 5. Okay? Negative 5. Okay? Then equals, our gradient is 1 over 5. M in this case represent what? Gradient. Okay? So x, then minus x1 is what? Negative 2. Okay, so when substituting, the only letter to substitute is 1, 1. This will remain just like that, will remain constant. It's just y1 and x1 there. Okay, that you should take note. Then from there now, we can simplify this. So y, negative times negative there to be positive 5. Okay, because 1 over 5. Negative time there to be x plus 2. Okay. Yes. So then from there, we are going to say y plus 5, because when we multiply this, what are we going to have? Automatically, we are going to have 1 over 5x, then plus 2 over 5. Okay, that is the equation. Now from there, we can actually correct the like terms, okay? So that we leave it in an expressed form. Explicit form. That means y should be the subject of everything. Okay? So we are going to say y equals 1 over 5, x there, then plus 2 over 5. Then this 5, when this 5 goes to the crosses an equal sign, it will automatically become a negative now. Okay? Okay, so here we are, y is equals to. So from there, we can actually now simplify this. Okay, so we have 1 over 5x. What is common there? Here we can say plus 2 over 5, then minus 5 over 1. So what is common here? So we are saying y is equals to 1 over 5x, then plus 5 is common. Then 5 into 5 times 2, 2 minus 5, then 5. Okay? 1 into 5 is 5. Then 5 times 5 is 25. To be 25 here now. Not 5. Okay? 25. Then y equals 1 over 5x. When we subtract this, we are going to have minus 23 over 5. Okay. So if you want now, if you don't want to leave that equation in that form, then again let me wrap this part of the board so that you can have space to write. Okay, so we are, the expression that we have here is there is y is equals to 5, then x minus 23 over 5. Then from there, we can now eradicate the fractions. How? The common factor here is 5. So 5 throughout, okay? So 5 times 3y is 5y equals, here we have this will go. 1 times x, we are going to remain with x. Then minus this will go. Then 1 times 23 is 23. Therefore, the equation. So the equation of the norm is 5y equals x minus 23. That is how we find the equation of either the norm or the tangent. Thank you so very much for your attention. Please continue listening so that you get more skills.